Hi, 8th grade. Okay, we're going to do lesson 3, session 3, describing a sequence of rigid transformations. Remember, a sequence means that there are more things that happen than just one thing. Now, I was excited when I saw this because I love the game Tetris. And if you've ever played the game Tetris, you can move the shape, you can rotate it, and then you can move it left and right, and then you can move it down so that it lands quicker. And I played Tetris all the time when I was a kid, and I never even thought that it was a math game, but it is. So during Tetris, basically, you're just doing a sequence of rigid transformations. Paula plays a game on her phone where she needs to fit the shapes together. Figure J will fit into the space right here. Only if the figure and the space are congruent. Describe a sequence of 2 transformations that move the shape into its space. So if I were playing this game, I would rotate the shape, let me grab a highlighter, I would rotate the shape this way, 90 degrees, and why not 180? Well, if I rotated it 180, this little piece that sticks out would be over here. And I don't want it over there. I want this piece to go downwards. I want that piece to fit in there. So I'd rotate it 90 degrees clockwise, and then once it's rotated 90 degrees clockwise, I'm going to want it to slide down into its spot, okay? So we could try to draw that for ourselves, but if you look at the next page, they drew it for us, and I think that that's more helpful to look at these than it is to try to do it ourselves. So let's go to the next page. So we can start by rotating. So here's a good picture of the rotation that happened. I would say it rotated 90 degrees with the center of rotation being the origin. And you can kind of see, because can you see how it kind of pivoted right there? So all of this rotated 90 degrees this way, and it landed in J prime. Now I want J prime to go down 1, 2, 3, 4 units. Okay, so I could describe the sequence of transformations by saying rotate 90 degrees clockwise about the origin, and then I would want to say move J prime 4 units down. So it's the 2 different transformations that need to happen. This picture says you can start by translating and then rotate about the origin. So what they did, I don't like this one. I prefer this one up here. I like the idea that they rotated it first, bloop, and then they moved it down. I don't like this one. They're saying move it 4 over, and then if you were to rotate this, it'd fit in there. I mean, yes, technically it would, but the real game of Tetris, that would hit these blocks right away, and then it would not be able to fit in. So technically, mathematically speaking, yes, you could rotate it, or you could translate it 4 units to the right, and then rotate it 90 degrees clockwise about the origin, and it would fit in there. But if you're thinking Tetris style, the game, if this was rotating, boom, it hit those blocks. So that's why I'm not a huge fan of this option, because the gamer in me says, no, that's not going to work. Okay, so let's go ahead and work on some of the questions. Look at both of the picture-its. Explain how the figure was transformed in each. So we're going to do picture-it number 1 and picture-it number 2. Okay, so let's go explain number 1. Let's see, number 1, first, rotated 90 degrees clockwise about the origin, and then translated 4 units down. Okay, now number 2 translated 4 units right and then rotated 90 degrees about the origin. Okay. Look at the longest side of figure J and the corresponding side of figure J prime, double prime. Are the sides horizontal or vertical? Well, let's go look. So we're looking at the longest side of J and then looking at the longest side of J prime. So I'm going to highlight the longest side of J, which is the 3 right here, 1, 2, 3, and then it translates over here to J double prime. So it's saying, are the sides horizontal or vertical? How could this help you decide whether or not to include a rotation in the sequence? Well, the side starts out vertical and then it rotates horizontal. So if you didn't know that this figure rotated to get to that spot, you could use those sides and say, well, how on earth does the side go from being vertical to horizontal? And usually that means because there was a rotation. So it's kind of a silly question. We're just going to say, I'm going to zoom in for you guys. It starts out vertical and ends up horizontal. This shows us that the shape rotated. Okay, number 3. Why is one rotation around the origin not enough? What else is needed? Well, because if you just did the rotation about the origin, your shape would just be stuck right here. You need it to go 4 down so it slides into position down here. I'm going to say, once the shape has rotated, comma, you need to translate it four units down so that it'll fit in the space. Number 4, is it possible to map figure J onto figure J double prime if one or both of the two transformations in the sequence is a reflection across the x-axis? Oh, weird. Let's think about that for a second. So it's saying, what if I took J and reflected it across the x-axis, so then it would look something like this. They're saying, could I reflect it and then be able to? Maybe I could reflect it and then rotate it 90 degrees, but not about the origin. I'd have to rotate it 90 degrees with like the center of rotation like being over here. That way it totally rotated. That's kind of a strange question. That really makes you think for a second. I think you could, but I think it would also run into these blocks. Like if on real Tetris, you don't want it to run into those blocks. So I'm going to say no. You can't do the reflection and then rotate it. You'd have to rotate it first. Number 5. How can comparing a figure and its image help you describe a sequence of transformations that showed two figures are congruent? Okay, so it's kind of like saying, how can you prove that that's what happened to the figure? Well, I can prove that that's what happened to the figure by comparing corresponding sides and angles. Okay. Number 6, reflect. Think about all the models and strategies we have discussed today. Describe how one of them helped you better understand how to solve the try-it problem. I want you to do this one on your own. I'll give you my opinion. I like picture it number 1, because picture it number 2, I just don't like the idea that it slid first and then rotated into its spot, because in real Tetris, I would probably have rotated that and then hit down to make it slide down. So that's what I would put right here, is I would put that I like picture it number 1 because it makes more sense in how the game should work. Alright, but you can put what you think. Number 7. You want to pause the video so you can go finish number 6, but then come back and we'll do number 7. Okay. Figure P is congruent to figure Q. Okay, duh. Describe a sequence of transformations that show this, and show your work. Okay, so what could we do? What could we do to show that P is congruent to figure Q? Can we show like how we could get P to land on Q? Because if P landed on Q, wouldn't it show that it's perfectly congruent to one another? Okay, so here's what I'm thinking. First, we should probably rotate P up into this quadrant. Now, if I'm rotating something just up one quadrant, that's a 90-degree turn. Once I rotate P up into this quadrant, it's going to look something like this. It's going to go about to there on the bottom, so that's going to be there. And now this is where it's kind of tricky. I think it's going to be about here is where that little top goes. And then it's like the thin side and then the more steep side. Because do you see how like this dot is only 1 away from this dot, really? It goes 1 and then over. But then this dot is like 2 away, because you would go over, then down. So there is like a side that's more steep than the other. This is the more steep side. Right there. Okay. So now if I were to translate my shape, just translate it 1, 2, 3, 4, 5 to the left, it wouldn't land perfectly on it. I'll show you. Do you see how it doesn't land perfectly on it? It's because there's one side that is more steep, okay? So now what do I need to do to get this to land perfectly on Q? Well, to me, it looks like we would need to use Y as a line of reflection and reflect it over there. Because then if I reflected this, it would land perfectly on Q. So go ahead and draw what I just did. And then we're going to say describe that transformation. So we're going to say rotate P 90 degrees counterclockwise. About the origin. The origin was our line, or our point of rotation, our center of rotation. Then reflect the image across, oops, Zach, how do you spell across? Is it A-C-R-O-S-S or A-C-C-R-O-S?
A-C-C-R-O-S. It's 2 S's.
It's 2 S's?
A-C-R-O-S-S.
Okay, I'm glad I fixed it. Okay, number 8. Figure A and figure B are congruent rectangles. Okay? Which sequence of transformations could show this? Basically, how do I get A to land on B, or how do I get B to land on A? Let's go ahead and see. It says select all that apply, so there could be more than one answer. rotate figure A 90 degrees counterclockwise. So it'd land like here. Oh no, that's clockwise. Counterclockwise. So it would go boom, rotate over here. Gosh, that's a tricky one. Then translate the image 1 unit up. Well, you know what? I don't think that if I were to rotate this, I think it would be like this. Yeah, there we go. Okay, so if I were to rotate this 90 degrees that way, it would turn out like that. Then if I were to move it 1 unit up, it would go like this. No, A doesn't work. Okay, how about B? Let me erase my stuff real quick. B says translate figure A 4 units to the right. 1, 2, 3, 4, so it'd be like this. And then 1 unit up. Yep, then it would land perfectly on B. We like that one. Let me go ahead and erase my doodles and we'll try C. C says translate figure A 1 unit up. Okay, so it did look like this. So far so good. Then reflect it across the x-axis. Well, you guys, if I reflected that across the x-axis, I'd be right back to where I started. So no, C doesn't work. Okay. Rotate figure A 180 degrees around the origin. Okay, so if it's gonna rotate 180 degrees around the origin, it's just gonna land right there. Perfect, that was easy. D works. Okay, let's try E. Reflect A across the x-axis. Okay, so if I did that, it would be here. So far, so good. Now move over, come on. Then reflect it across the y-axis. Okay, there we go. I like that. It would land right on B. Okay, F. Reflect figure A across the y-axis. Okay, so that means it'd flip over here. And then translate it 1 unit up. Yeah, there we go. I like F too. There's a lot of correct answers on that question. Okay, number 9. Figure H is congruent to figure H prime. Describe 2 different sequences of transformations you can use to show this. Let's think about this. I could reflect it across the y, and then it would look something like this. 1, 2, diagonal. 1, 2, 3, and okay. So it would look something like that after I reflected it. And then if I could translate the whole thing over 1, 2, 3, 4, that'd work. Okay, so I'm gonna write that down. It says you can use to describe 2 different sequences. Okay, so my number 1 sequence is reflect across the y-axis, then translate 4 units to the right. Okay, that's what my brain automatically saw to go do. So now I have to use a different part of my brain to try to see this in a different way. Okay, so how else could I do it? I know they're going to want to say something about rotating. Why do I have a feeling they want us going to rotate it? Four units to the left. And then a reflection? Oh, that's interesting. What if I took H prime? No, I gotta start with H, sorry. What if I started with H and I moved it 4 units this way? So it'd be 1, 2, 3, 4. Oh gosh, I'm having a really hard time drawing this for the second time. It would look like this. 1, 2. Oh, it only goes 2. Then it goes down. There we go. Let me erase my little ducktail. Okay, so what if I move it 4 units, then reflect? Oh, so it's basically what we just said. It's just moving it first. Okay, so let's do that. Number 2. Move H I'm going to say reflect across the y. Okay, so move h 4 units left, then reflect across the y-axis. Okay. Alright guys, so we will do 59 and 60 in class. Please take a picture of 58, page 58, and then upload that. We write down any questions you have from this lesson. It's pretty simple, just a system of different transformations. Alright, bye guys.